The National Electrical Code, specifically Section 422.33, addresses the requirements for refrigerator outlets. This section stipulates that the outlet must be located not more than 42 inches above the floor, not less than 12 inches above the floor, and not more than 6 feet from the front of the enclosure. It also mandates that the outlet be readily accessible. This accessibility is intended to facilitate easy resetting of circuit breakers or replacement of fuses, which can be difficult if the outlet is located in less accessible areas. Now, while the code emphasizes accessibility, a common practice is to install refrigerator outlets above the countertop, often within a cabinet or directly behind the refrigerator. This is frequently done for aesthetic reasons or due to space limitations. However, it's crucial to understand that this common practice does not align with the strict interpretation of NEC 422.33 regarding accessibility. There is no specific escape clause within NEC 422.33 that explicitly permits placing the outlet above the countertop while still meeting code requirements. The code intends for the refrigerator outlet to be easily accessible for maintenance and safety purposes. Inspectors might interpret the code differently. Therefore, adhering to the NEC intent by installing the outlet in an accessible location is advisable. Now, regarding additional considerations, if it's impractical to make the refrigerator outlet easily accessible, installing a remote outlet switch could be a solution. This would allow for resetting the circuit from a more convenient and accessible location. For commercial kitchens, it's paramount to remember that the refrigerator outlet must be GFCI protected, regardless of its physical location, to enhance safety and prevent electrical hazards. In summary, while aesthetic and spatial constraints often lead to placing refrigerator outlets above countertops, NEC 422.33 prioritizes accessibility for safety and maintenance. Consider a remote switch if direct accessibility is challenging, and ensure GFCI protection in commercial kitchens to align with code requirements. Let's delve further into the technical aspects of NEC 422.33 and its implications for electrical installations. The 42-inch height restriction is designed to ensure that the outlet is within reach for most individuals, allowing them to easily access it for troubleshooting or maintenance purposes. The 12-inch minimum height prevents the outlet from being too close to the floor, which could expose it to moisture or other hazards. The 6-foot distance from the front of the enclosure ensures that the outlet is conveniently located near the refrigerator without requiring excessive reaching or maneuvering. The term readily accessible is a key element of NEC 422.33. It implies that the outlet should be accessible without requiring the use of tools or the removal of obstacles. This means that placing the outlet behind the refrigerator, where it is obstructed by the appliance itself, would not meet the code's definition of readily accessible. Similarly, placing the outlet inside a cabinet above the countertop, where it may be difficult to reach or require the use of a step stool, would also be considered a violation of the code. Now let's examine the potential consequences of non-compliance with NEC 422.33. Firstly, it could result in a failed electrical inspection, which would delay the project and require costly rework. Secondly, it could create a safety hazard, making it difficult to quickly reset the circuit breaker in the event of an overload or short circuit. Thirdly, it could increase the risk of electrical shock or fire, particularly if the outlet is located in a damp or humid environment. Therefore, it is essential to carefully consider the implications of NEC 422.33 and to ensure that all refrigerator outlets are installed in accordance with the code's requirements. Now, let's discuss some practical solutions for complying with NEC 422.33 while still addressing aesthetic and spatial concerns. Firstly, consider installing the outlet on a side wall adjacent to the refrigerator enclosure, at a height between 12 and 42 inches above the floor. This would provide easier access to the outlet without compromising the aesthetics of the kitchen. Secondly, consider using a surface-mounted outlet box, which can be easily installed on an existing wall surface without requiring extensive modifications. Thirdly, consider installing a recessed outlet box, which can be flush-mounted with the wall surface for a cleaner and more streamlined appearance. In addition to these practical solutions, it is also important to educate homeowners and contractors about the importance of complying with NEC 422.33. By raising awareness of the code's requirements and the potential consequences of non-compliance, we can help to ensure that all refrigerator outlets are installed safely and correctly. Now let's shift our focus to the GFCI protection requirement for refrigerator outlets in commercial kitchens. A GFCI, or ground fault circuit interrupter, is a safety device that is designed to protect people from electrical shock. It works by monitoring the flow of electricity through a circuit and quickly interrupting the power if it detects a ground fault, which is a condition where electricity is leaking to ground. In commercial kitchens, where there is a higher risk of moisture and spills, GFCI protection is essential for preventing electrical shocks and injuries. NEC 210.8 specifies the requirements for GFCI protection in various locations, including commercial kitchens. The code requires that all 125 volts, 15 amps and 20 amps receptacles installed in commercial kitchens be GFCI protected. This includes refrigerator outlets, as well as outlets for other appliances and equipment. There are two main methods for providing GFCI protection for refrigerator outlets. Firstly, you can install a GFCI receptacle, which is a special type of outlet that has a built-in GFCI. Secondly, you can install a GFCI circuit breaker, which is a special type of circuit breaker that provides GFCI protection for the entire circuit. When choosing between these two methods, it is important to consider the specific needs of the installation. GFCI receptacles are generally less expensive and easier to install, but they only protect the outlet to which they are connected. GFCI circuit breakers, on the other hand, provide protection for the entire circuit, which can be more convenient and cost-effective in some cases. Regardless of which method you choose, it is important to ensure that the GFCI device is properly installed and tested to ensure that it is functioning correctly. This typically involves pressing the test button on the GFCI device and verifying that the power to the outlet is interrupted. In addition to the GFCI protection requirement, it is also important to ensure that the refrigerator outlet is properly grounded. Grounding provides a safe path for electricity to flow in the event of a ground fault, which helps to prevent electrical shocks and injuries. The NEC specifies the requirements for grounding in Article 250. The code requires that all electrical equipment be properly grounded, and it provides detailed instructions on how to achieve proper grounding. In most cases, grounding is achieved by connecting the metal enclosure of the electrical equipment to a grounding electrode, such as a ground rod or a metal water pipe. The grounding electrode is then connected to the building's grounding system, which provides a path for electricity to flow back to the source in the event of a ground fault. By following these guidelines and adhering to the requirements of the NEC, you can help to ensure that refrigerator outlets are installed safely and correctly, protecting people from electrical shocks and injuries. Now, let's address some common misconceptions about NEC 422.33. One common misconception is that the code only applies to new installations, and that existing installations are grandfathered in. However, this is not the case. The NEC applies to all electrical installations, regardless of when they were installed. If an existing installation does not comply with the current code requirements, it must be brought up to code when it is modified or repaired. Another common misconception is that the code is only a set of guidelines, and that it is not legally binding. However, this is also not the case. The NEC is adopted into law by most states and local jurisdictions, which means that it is legally binding. Failure to comply with the code can result in fines, penalties, and even legal action. A third common misconception is that the code is too complicated and difficult to understand. While the NEC can be complex, it is important to remember that it is designed to protect people from electrical hazards. By taking the time to learn about the code and how it applies to your specific situation, you can help to ensure that your electrical installations are safe and compliant. To further clarify the requirements of NEC 422.33, let's consider some specific examples of compliant and non-compliant installations. A compliant installation would be a refrigerator outlet located on the side wall adjacent to the refrigerator enclosure at a height of 36 inches above the floor with a readily accessible GFCI receptacle. This installation would meet all of the requirements of NEC 422.33 as well as the GFCI protection requirements for commercial kitchens. A non-compliant installation would be a refrigerator outlet located behind the refrigerator at a height of 48 inches above the floor without GFCI protection. This installation would violate the accessibility requirements of NEC 422.33 as well as the GFCI protection requirements for commercial kitchens. Now let's discuss the role of electrical inspectors in enforcing NEC 422.33. The electrical inspectors are responsible for ensuring that electrical installations comply with the requirements of the NEC. They typically conduct inspections at various stages of a construction project, including the rough-in stage, the final stage, and the renovation stage. During these inspections, they will verify that all electrical equipment is properly installed, grounded, and protected. They will also check to ensure that all outlets are located in accessible locations and that GFCI protection is provided where required. If an electrical inspector finds a violation of NEC 422.33, they will typically issue a notice of violation, which requires the contractor to correct the problem within a specified time frame. Failure to correct the violation can result in fines, penalties, and even the shutdown of the project. Therefore, it is essential to work closely with electrical inspectors throughout the construction process to ensure that all electrical installations comply with the requirements of the NEC. Remember, it's always best to consult with a qualified electrical professional for specific guidance on your electrical installations.